Two positive charges are kept in air 0.1 meter apart, experience a force of 16.2 Newton. Okay, so there are two positive charges which are separated by some distance, right? And they are separated by 0.1 meter distance. And these two charges, they experience a force of 16.2 Newton. The force between them is 16.2 Newton. If one charge is 6 microcoulomb, then we need to find what is the other charge. Then in between these two charges, if a third charge is brought, that is of 2 microcoulomb, then which is present at a distance of 0.04 meter from the first charge, then find the resultant force acting on the third charge. So this is the problem. It is very simple. See, first let us write the given things. Let us consider the first charge as 6 microcoulomb. We don't know the second charge, that has to be calculated, and the third charge which is placed in between, it is of 2 microcoulomb. Now the distance of separation between Q1 and Q2, right? If you consider 3 points there, if you assume 3 points there, like the first point is A, second point is B, and the third point is C, right? Then the distance between A and B, AB, that distance is 0.1 meter, and the distance between A and C is 0.04 meter. Then the remaining distance, that is BC, which is also necessary, it is 0.06 meter. Okay. Now the force which is present between A and B, the 2 points or the charges which are present at A and B, that force is 16.2 Newton. So all the information has been written. We have written all the given information. Now first let us start off with the force only, right? So the force which is there, the force present between the two charges, which is taken as F between A and B, is, the formula is 4 pi epsilon naught into QA QB divided by the distance square, that is AB square. See, it is 9 into 10 raised to 9. The force is also given, that is 16.2 into QA is there, 6 microcoulomb, 10 raised to minus 6. But I don't know what is QB, right? So, or Q2, right? And divided by, what is AB? AB is 0.1 whole square. So, simplify the RHS. It is 9 6 54 into 10 raised to 9 minus 6 divided by 0.1 whole square is 0.01 or 1 into 10 raised to minus 2. And QB or Q2, it is kept as it is. Then you simplify the terms by taking all the numerical values to left hand side. Then it will be Q2 is equal to 16.2 into 10 raised to minus 2 divided by 54 into 10 raised to 3. Okay. Now what is this 16.2 divided by 54? Yes, what is the value of that? Yes, anybody? Anybody?
0.3.
0.3 into 10 raised to minus 2 minus 3. Okay, this 3 goes to the numerator, it becomes minus 3. Hence Q2 is equal to, it is 0.3 into 10 raised to minus 5. Or if you don't want this negative, decimal point there, then Q2 is equal to 3 into 10 raised to, just you increase it, then it is minus 6 coulomb or 3 microcoulomb. Okay, so that is the value of Q2. First part of this problem is solved. Any doubt or any questions here? Anybody has any doubt or any question? Yes. Now the new thing, that is introduction of a third charge at one particular point, that is C. So when Q3 is placed at C, then that the charge experiences the force, right, from the first charge, that is Q1 as well as Q2, the second charge. Okay, so therefore first we have to consider the force experienced by first charge. Force on Q3 due to charge Q1. Okay, so it can be written as F, I write it as F1. Okay, F1, 1 divided by 4 pi epsilon naught into Q1 Q3, because it is the force between Q1 and Q3. Okay, then the distance between them, it is AC square. Yes, so therefore F1 is equal to 9 into 10 raised to 9. Substitute the values. Q1 is 6 microcoulomb, 6 into 10 raised to minus 6, and Q3 is given as 2 microcoulomb, isn't it? So it is 2 into 10 raised to minus 6. Right, whole divided by AC square. AC is 0.04 whole square. See, this is 9 into 6 into 2. See, it is 12 nines are. How much is 12 nines are? 108, isn't it? Into 10 raised to 9, minus 6 is minus 12, then divided by this 0.04 whole square is 0.0016. I repeat, 0.0016. Therefore, it is 16 into 10 raised to minus 4. Okay. So, what is left now? See, we are left with 108 divided by 64. Sorry, 108 divided by 16 into 10 raised to. See, if the denominator is taken to numerator, then it is 10 raised to minus 3 plus 4. Okay, so 10 raised to minus 3, then it becomes plus 4. So what is 108 divided by 16? It is 6.75 into 10 raised to 1, or F1 is equal to 67.5 Newton. So call it as equation 1 or result 1. Any problem? Yes. Similarly, you go for the calculation of another force, that is force between Q2 and Q3. Okay, Q2 is present at B and Q3 is present at C. What is the force between them? So that we have to calculate. Now, F2 is what? Force between Q2 and Q3. So that is written as same formula, 4 pi epsilon naught into Q2 into Q3. See, that is the change here. Then what is the distance? The force is between the two charges, Q2 and Q3, which are placed at B and C, isn't it? So therefore you have to take BC square. See, 9 into 10 raised to 9. Then Q2 is, already we have calculated Q2, it is 3 microcoulomb. Hence it is 3 into 10 raised to minus 6. Q3, it is given as 2 microcoulomb. Okay, 2 microcoulomb. So 10 raised to minus 6 divided by. What is BC? See, we have noted BC as 0.06. Therefore, it is 0.06 whole square. Now, just you multiply 9 and 6, because 3 2s are 6, 9 6 are 54, into 10 raised to 9 minus 12, and denominator will be, see, it is 0.0036. Square of 6 is 36, isn't it? Hence, F2 is equal to 54 divided by 36 into 10 raised to minus 3, then plus 4. So how much is 54 divided by 36? It is 1.5. 1.5. 54 divided by 36 is 1.5 into 10 raised to 1, or it is 15 Newton. That is F2. Now, how these two forces are? They are opposite in direction. F1 and F2 are opposite in direction. Okay, both are acting on the third charge. Therefore, resultant force on the third charge, on the charge Q3 is, yes, that is F is equal to F1 minus F2, right? So F1 is 67.5 minus F2 is 15 Newton. Then just you take the difference of them, then it is 52.5 Newton. That is the net force which is acting on the third charge. Hope the solution is clear to you. Hope it is clear to all of you. See, the question is, they ask you to find the resultant force on the third charge. Okay, they ask you to find the second charge, and also they ask you to find the resultant force on the third charge. Hence, both are calculated here. So it is again a special example which might be useful for you. Okay, hope you got the solution. If you have any doubt, you can ask. Then, now I am moving to the 10th problem. See, this 10th problem is different from the problems what we have solved, because now I am considering the concept of electric field at one particular point. So you have to recall the theory information or the theoretical concept what you have learned regarding the electric field. Yes. So what do you mean by this electric field? See, electric field, it is nothing but the force experienced by a unit positive charge. Right? Electric field at a point is the force experienced by a unit positive charge. Hence, the formula of electric field is given by E is equal to 1 divided by 4 pi epsilon naught into Q divided by R square. So this is the formula what we have learned. Okay, so whenever you come across the concept of electric field at a point, then you have to make use of this formula. And remember that this Q is the charge due to which the electric field is created. So it is the source charge. So don't be under the confusion. Dear students, remember that it is the source charge because of which the electric field is created in one particular region. Okay. So while making the calculation of electric field at a point, we do not consider the charge of the test charge or magnitude of the test charge. Okay, so we only consider the charge of the source charge. Yes. Now let us begin our concept. See what they have given. They have given that a point charge of -4 microcoulomb is placed at A. See, A is a point, and at this point -4 microcoulomb of charge is placed. What is the electric field at point B? See, there is one more point, say B, which is present at a distance of see 0.2 meter from A. So at this point you have to calculate what is the electric field. Very simple and direct question. Particularly I have selected this so that you can understand the simple question first. Later we can move to the difficult questions. Right. Now there is one more extension. What is that? If a point charge of plus 10 nanocoulomb, okay, so N stands for nano, plus 10 nanocoulomb is placed at B, then find the force acting on it. Yes, definitely we know that whenever any charge is placed in an electric field, it experiences the force. Hence we have to find that force. The concept is direct one and very simple. So I'm not considering the second part now. I'm not taking this part. Okay, I'm focusing only on the first part. Yes, what are the given things here? Given the charge Q, source charge is -4 microcoulomb. The distance which is present there, it is 0.2 meter. Yes, only two things are sufficient. Then we know that, what we know, that E at B, electric field at the point B is 1 divided by 4 pi epsilon naught into Q divided by the square of the distance. That is 9 into 10 raised to 9 into, yes, what is Q here? It is 4 microcoulomb. So 4 into 10 raised to -6 whole divided by, or divided by 0.2 whole square. The distance is 0.2 there. So therefore it is 9 fours are, just to multiply there. Okay, 9 fours are 36 into 10 raised to 9 minus 6 whole divided by, see 0.2 whole square is nothing but 0.04. Yes, it is 0.04. Therefore, E is equal to, electric field at B is 36 into 10 raised to 3 divided by, see 4 into 10 raised to -2. So therefore, E is, yes, 4 how much are 36? 9 are into 10 raised to 3. This -2 becomes +2. Then it is 2. Therefore, now the final answer is 9 into 10 raised to 5. Yes, what is the SI unit of this electric field? Fast. What is the SI unit of electric field? Newton per coulomb. Okay, the SI unit is Newton per coulomb. Remember, dear students, if you don't write the SI unit, then you are not going to get the full marks there. They will deduct either half marks or 1 marks. Any problem? It is a simple and direct question what I have taken. Next, the second part now. If a test charge, okay, how much is the value of the test charge? Plus 10 nanocoulomb is placed at B. See, already A is there. At A we have -4 microcoulomb, and B is the distance, is the point present at a distance of 0.2 meter, and at this we place 10 nanocoulomb. Then definitely it will experience the force. What kind of force? It will experience it, and experience the attractive force. Okay, it will experience the attractive force. See, even you can consider the distance there. Yes, you know how to solve this. Very simple. Yes, you don't need my help here. You can solve along with me, right? Just I will make some space here. Write the formula, that is force experienced by the charge 4 pi epsilon naught into q1 q2 divided by distance square, that is r square. So it is 9 into 10 raised to 9. Yes. What is q1? Q1 is, it is 4 minus 4 or 4. So 4 into 10 raised to minus 6. Q2 is 10 nanocoulomb. Observe here carefully. 10 into 10 raised to minus 9. Nano
Yes,
means
sir.
9. 10 raised to minus 9. Right? Then what is the distance here? Distance is 0.22 square only. Distance remains same. So observe one thing here. 10 raised to plus 9, 10 raised to minus 9 cancel. Okay. So it is 9 into 4 into 10 raised to minus 6 whole divided by zero point 0.2 whole square is nothing but 4 into 10 raised to minus 2. Okay, as we did in the previous case, it is 4 into 10 raised to minus 2. Again 4 cancelled. Then here 9 into 10 raised to minus 6 is already there. Then the denominator becomes plus 2. Right? Hence F is equal to 9 into 10 raised to minus 4 Newton. Okay, so this is the force experienced by the charge, the test charge, that is 10 nanocoulomb, which is placed at the point B. Yes, dear students, do you have any doubt or any questions? You may ask. Any doubts? Are you following all the steps here? Are you following all the steps? What I am
Yes, sir.
taking? Yes. I think the concept of nano is clear. Nano, because I think this is the first time in which nano has appeared. Okay, in first year if you have learned perfectly, then no problem. We don't have any doubts, right? If somebody has not learned perfectly in the PU first year, then here they get the chance to learn. Okay, now I continue with the third problem. Yes, a very interesting one. 2-point charges plus 2 microcoulomb and plus 6 microcoulomb are separated by a distance of 10 centimeter. They say that there are two charges. One is 2 microcoulomb and another one is 6 microcoulomb, which are separated by a distance of 10 centimeter. 10 centimeter is nothing but 0.1 meter. Okay. Yes. What is the electric field at the midpoint of the line joining the two charges? See, very important. You have to find the electric field at a point, that is which is present at the midpoint. See, suppose A is one point, B is the other point where the charges are present, and M is the midpoint of AB. Then at M you have to calculate the electric field. Okay, so this is the change what we find in the problem. In the second problem, in the second case, if a positive test charge of 5 microcoulomb is placed at that midpoint, what is the force experienced by the test charge? Okay, so the same thing, just like how it is considered in the previous problem. Here also, if one test charge is placed at M, then what will be the force experienced by it? Right. Now, my question is, how many source charges are present here? Whether only one source charge is there, or two source charges are there, or three? Yes. ಬೇಗ ಟೈಮ್ ಹೋಗ್ತಾ ಇದೆ. See, there are two source charges. One is 2 microcoulomb and another is 6 microcoulomb. Both are source charges only. Okay, because the electric field is due to the combination of these two charges, right? It is due to the combination of these two charges. Both act as the source charge only. Then how to find the field here? First, what you have to do? First, you have to find the electric field at M due to 2 microcoulomb. Next, you have to find the electric field at M due to 6 microcoulomb. Then you have to go for resultant electric field at M. So remember my words. Okay? Yes. And here the direction is also very important. See, direction is also very important. So electric field due to the first charge, say Q1, which is 2 microcoulomb. See, it will be away from M. Okay, E1 will be away from M. Why? Because there will be repulsive force, and in the direction of the force, the electric field will act. Similarly, electric field due to the second charge, it is E2 and it will be in this direction. Now, if you find E1 and E2 and as they are opposite in direction, just you take the difference between them, you will get the resultant charge. Any problem, any doubt, dear students? So, shall we start? Shall we start? Yes. So, first I consider, observe here, electric field due to Q1 at M. See, as it is midpoint, AM is 0.05 meter and BM is also 0.05 meter. Okay, as M is the midpoint. Correct. So therefore, it will help you while taking the electric field. So the formula is 1 divided by 4 pi epsilon naught. It is due to Q1. So write only Q1 there, and the distance between A and M whole square, that is AM square. Yes, substitute the values. 9 into 10 raised to 9 into Q1 is 2 into 10 raised to minus 6 whole divided by AM is 0.05 whole square. Any problem, any doubt here? Next, E1 is 9 2s are 18 into 10 raised to 9 minus 6 divided by, see, it is 0.05 whole square is 0.0025, or it is 25 into 10 raised to minus 4. 25 into 10 raised to minus 4. So that minus 4 goes to the numerator. Okay. So 18 divided by 25. 18 divided by 25 is 0.72 into 10 raised to 3 into 10 raised to 4. Okay. Because 9 minus 6 is 3. Minus 4 goes to the numerator. It becomes plus 4. Hence it is 0.72 into 10 raised to 7. Or you can write it as 72 into 10 raised to 5 Newton. So that is the force E1. Call it as 1. Now you go to the next part, that is electric field due to Q2 at M. Yes, follow the same procedure. Write the formula there. Now this time you have to take Q2 and the distance is BM. Substitute the values. Then 6 into 10 raised to minus 6 is the charge Q2. BM is same, 0.05 whole square. Therefore, E2 is equal to, see, 9 6 are 54 divided by 25 into 10 raised to 9 minus 6 plus 4. Okay, that is equal to, E2 is equal to, how much is 54 divided by 25. It is 2.16 into 10 raised to 9, 4, 13. 13 minus 6, it is 7. Okay. Now you can shift it. Shift the two decimal places. 216 into 10 raised to 5 Newton. Yes. Check it out. Check it out. Any doubt? Any question? Yes. Now the resultant electric field. Resultant electric field at M, at the midpoint, that is E is equal to, see which one is bigger here, E2 is bigger, therefore it is E2 minus E1. 216 into 10 raised to 5 Newton minus 72 into 10 raised to 5 Newton. So 216 minus 72, then the result will be 144 into 10 raised to 5 Newton. That is the resultant electric field. Sorry, it is Newton per Coulomb. Okay, Newton per Coulomb. Yes. So electric field is 144 into 10 raised to 5 Newton per Coulomb, because from last 3 days I am solving the problems on force. So therefore I took it as Newton, but it is Newton per Coulomb. Any problem? Any doubt? Then see, we have completed the part A here. Now we have to move to part B. See what we have to do. If a positive test charge of 5 microcoulomb is placed at that point, then what is the force experienced by it? Just I will give you the hint. Yes, just I will give you the hint so that you can able to solve it by yourself. Okay. See, this is A, this is B, and at the line joining the 2 points at M, we have one more test charge. What is that charge? 5 microcoulomb. So this is say Q3, and Q3 is 5 microcoulomb. Hope you got this. Q1 is 2, Q2 is 6. It is 2 microcoulomb and 6 microcoulomb. See what you have to do. When you place this charge 5 microcoulomb here, it starts to experience the force. So as these two, Q1 and Q3 are positive charges, Q3 experiences the repulsive force, and that force is F1. Similarly, Q3 experiences the force due to Q2. As both are again positive charges, so it also again experiences the repulsive force, that is F2. Okay. So now at first stage you have to calculate force on Q3 due to Q1, right? That force is, you call it as F1. You know the formula, that is 4 pi epsilon naught into Q1 Q3, okay, divided by the distance square, that is AM square. You make all the calculations, you will get F1. Some Newton you will get. Similarly, you consider the force on Q3 due to Q2. Okay, so you consider the formula F2. See, I am giving you complete hint regarding this. Okay, so Q2 Q3 divided by, what is the distance here? BM. So BM square. Then you substitute the values and calculate. You will get F2 some Newton. Okay, some value you get. Then you go for resultant force. Resultant force on Q3 due to Q1 and Q2. So you know that F1 and F2 both are acting in the opposite direction, complete opposite direction. Then simply you take the resultant force as F1 difference F2. See which force is more. Okay, so I think the force due to charge at B will be more because its magnitude is more. It is 6 microcoulomb, whereas here Q1 is 2 microcoulomb. So force due to Q2 will be more, hence it will be Q2 minus Q1. That's why I have written different sign. So you can make the analysis, and after observing the results what you get, you can write it as F2 minus F1, then substitute the values and make the subtraction there, then you will get the answer as few newtons, right? Any problem, any doubt? So I have given you the complete information regarding how to calculate the resultant force acting on Q3. It is your work. Okay, see, if I solve all the problems and if you don't solve at least few of the problems, then it's of no use. If you want to become perfect, then solve more and more problems, right? Do some extra work. Okay, then only you will get the grip on the problem section, and you can able to score in theory as well as you can handle the questions which are there in CET and NEET. Is it clear? Yes, dear students, with this I would like to stop the class. If anybody has got anything to say or any doubt, you can ask. Whether you are following the videos what I am sending on YouTube.
Yes, sir.
Yes, so follow the videos and make the note.